Hi everyone, in this video we're going to learn all about cracking, what it is and why we need it. So we've already seen in the previous video how crude oil comes into the oil refinery and through fractional distillation they separate it into all of these different useful products, with the smaller hydrocarbons coming out near the top of the column and the longer hydrocarbons coming out near the bottom. Now, here's the problem the oil companies face. If they did that on every barrel of crude oil that they get from deep underground under the sea, they would find that they'd have a lot of the longer hydrocarbons like bitumen left over, because there's a much higher demand for the shorter ones like petrol that make the good fuels than bitumen, which we need for making roads. So we need lots of the shorter ones, but we'd have a lot of the longer hydrocarbons left over. So here's the really clever thing that the oil companies do. They turn the leftover long hydrocarbons into the shorter hydrocarbons that we need more of, like petrol. And that process is called cracking. And we're going to see now how that's done. So we've got a hydrocarbon here, which is petroleum jelly, soaked onto some rock wool. And we're using some intense heat from the Bunsen burner to try and crack that hydrocarbon into smaller molecules. So it's going to pass into a vapour, and we're passing that vapour over the catalyst, which in this case is broken pieces of pop. So we're heating it up to a vapour and passing it over a hot catalyst. So we've been heating the hydrocarbon strongly, and any products given off are passing along this delivery tube, and we're using an upturned test tube of water to collect the gases given off. Now we've been letting the first amount of gas come straight out of the tube because that would just be the air expanding in the test tube and the delivery tube. But now it's been going for a while, we can collect this gas, and this should be the shorter alkane and also an alkene. So if we were then to test this with bromine water, it should turn the bromine water from orangey brown to colourless. Let's take a look at what happens if you crack decane, which has got 10 carbon atoms. So the molecule is heated up and the molecule vibrates more and more until at some point it breaks. So imagine it breaks into a molecule of 8 carbon atoms and another molecule with 2 carbon atoms. Now this molecule with 8 carbon atoms is a shorter alkane. In this case it's octane because it's got 8 black carbon atoms, but notice how we've now not got enough hydrogen atoms to go around. So this molecule forms a double bond, which means we've now got an alkene, in this case ethene. And alkenes can be made into polymers like polyethene, so that's also a very useful substance. If we look at the equation for cracking decane, you can see decane starts off with 10 carbon atoms as you expect, and we'd heat it up maybe with steam or a catalyst, and imagine the decane molecule cracks or splits down here, so we end up with a molecule with 8 carbons and 2 carbon atoms. So one of those will be a shorter alkane like this. This is octane, very useful alkane. It's the main chemical in petrol, so it's a good fuel because it's shorter, more flammable and so on. And we also see that we're making an alkene, in this case ethene. And alkenes are very useful because they can be used to join together and make into plastics or polymers. So that's how we could show the display formula of the molecules involved with cracking. Here we've got the molecular formulas, so we've got the decane molecule here breaking down to make octane and ethene. And this is a good example of a thermal decomposition reaction. That means using heat to break down a compound.